Hey folks, moving on to 6.3. Let's see. They say factor using the perfect square trinomial pattern. So let's take a look at 160. 25v squared plus 20v plus 4. So basically, I don't even know why they point things out that if you do enough of these, you start noticing some patterns. So I would suggest you just do the X method, the AC method, like you normally do. But they just wanted to point out that if you do enough of these, you'll start recognizing some patterns. So with this one, they wanted you to recognize that 25 is a perfect square, 4 is a perfect square, and then so if you were to just write down 5v plus 2, right? 5v times 5v is 25v, 2 times 2 is 4. 5v plus 2, 5v, so if you FOIL, right, 5v times 2 is 10v, plus 10v is 20v. So they wanted to just point out that sometimes things work out perfectly. They call it the perfect square trinomial pattern. Okay, so that. So again, just you do the X method, right, you'll get the same answer. With enough practice, you'll start recognizing some of these. How do I recognize it? 49 is a perfect square. 121 is a perfect square. So I'm just going to quickly guess 7x plus 11, 7x plus 11, 77 plus 77 is 154. Boom. Okay. So let's see. Does it get a little bit more tricky? Let's see. Let's try 172. 172. 64x squared y minus 96xy plus 36y. 172. 64x squared y minus 96xy plus 36y. Well, first thing I notice, they tried to trick us here. There's a y, there's a y, there's a y. Okay, well, let's get rid of the y. 64x squared minus 96x plus 36. Okay, and now let's factor this guy. Oh, 64 is a perfect square. 36 is a perfect square. So maybe, see how the y is going along for the ride? So maybe this thing is going to factor perfectly. Signs are the same, right, positive, and they're both negative. 64, so I'm just going to put an 8x and an 8x, and then 36, so minus 6, minus 6. 8x times 8x is 64x squared. Negative 6 times negative 6 is positive 36. Negative 48 gives us negative 96. Oh, cool, it worked. Now the back of the book, so I might have stopped there. The back of the book would say, oh, wait, these guys are both even. Why don't you pull out a 2? Why don't you pull out a 2? Oh, I guess in the very beginning I could have pulled out a 4. That means 64, 96, 36. When I pulled out a y, I could have also pulled out a 4. Okay. But anyhow, let's see. The y is going along for the ride. 8x minus 6. I'm going to pull out a 2. And that leaves me with a 4x minus 3. And then over here, I'm going to pull out a 2. Everything's just being multiplied. Leaves me with a 4x minus 3. So when the dust settles, there's a 2, and a y. So there's a 4y. And then there's a 4x minus 3. And there's another 4x minus 3. Maybe even the back of the book said since 4x minus 3 times 4x minus 3, they might have even put a little square there. I just leave it like this. So here is our answer, 172. Okay. So another thing. So these are just sort of special cases. Let's take a look at 176. We have, what do we have? 169q squared minus 1. So you see how there's no middle term, there's no q stuff. Perfect square, and there's difference. So if you have difference of squares gives us that conjugate trick. 13 times 13 is 169, so 13q plus 1, 13q minus 1. Conjugates, remember the only difference is the sign, so 13q plus 1, 13q minus 1. 13q times 13q is 169q squared. Positive 1 times negative 1 is negative 1. Negative 13q, positive 13q cancel. So if you FOIL, outsides and insides go bye-bye. Okay. So now that we see the pattern, 178, 121 minus 25, x squared. It says s. I like putting x's. So that's 11 squared, that's 5 squared, that's x squared. So you could just really quickly just say that's 11 minus 5x plus 5x. Too easy? 180, 98, r, I'm going to change it to x cubed minus 72x. So before you jump into it, you say, oh, what can I pull out from everybody? That's what I didn't do earlier. I always forget to do that. I can pull out an x from everybody, and they're both even, so I can pull out a 2. So if I pull out a 2 and an x from everybody, that's going to leave me with a 49x squared minus 36. 2 times 49 is 98, x times x squared x cubed, 2x times that, negative 72x. Just double check. Okay, now let's break this apart. Oh, perfect square, perfect square, perfect square, minus sign, difference of squares. So 2x, and so 49 x squared, 7x, 7x, 36, 6, 6, plus, minus, conjugates, done. Boom! 188. 188, we have m to the fourth minus n to the fourth. So m to the fourth is technically m squared times m squared, and that's n squared times n squared. So couldn't I just go m squared times m squared is m to the fourth, n squared times n squared is n to the fourth, and the middle terms cancel, so 1 plus 1 minus. Cool. Now, difference of squares can be broken apart more. Addition of squares cannot be broken up, so this one's done. So that's just m squared plus n squared. But this guy, we could rewrite as, boom, m plus n, m minus n. And we're done. Okay. The next section, 195. They use this formula, difference of cubes. So everything's making perfect sense, I'm assuming right now. And then now they throw a curveball at us. So you need a little formula. A cubed minus b cubed, we need a formula. And a cubed plus b cubed, we need a formula. So here's how I remember the formula. Just scroll back in 6.3, you'll see the formula. But if you ever have to memorize it, which you don't need to this semester, but if you ever do, what I remember is there's just one minus sign. So a cubed minus b cubed, that's going to be a minus b. So this guy's a plus b. And then it's a squared, and then it's just plus signs. Plus ab plus b squared. And then this would be a squared minus ab plus b squared. So you can see the formula in the book. So the formulas look the same. Notice there's only one minus sign in the formula. There's only one minus sign in the formula. No numbers, no numbers. Okay. So, again, just look it up. But if you ever had to memorize it, that is my mnemonic. Let us do 196. N, oh gosh. Is there an easier one? We'll come back to 196. Let us do an easier one. Good gosh, are there any easy ones? 200. 125 minus 27w cubed. So because there's a cubed, I'm thinking, oh, there's going to be the cube formula we just learned. 125, 5 times 5 times 5, so that's 5 cubed. 3 times 3 times 3 is 27, so that's a cube, that's a cube, that's a cube, right, w cubed. Oh, so this is difference of cubes. So let me rewrite this as something cubed minus something cubed. 125 we said was 5 cubed. And how do we get this mess here? 3 and w, right? Because the 3 cubed is 27, w cubed. So far so good. So I'm going to plug this into the formula of a cubed minus b cubed, which we agreed to a minute ago is just going to be a minus b, a squared plus ab plus b squared. Okay, so a is just 5. B is just 3w. Okay, so I'm just plugging things in. 5 minus 3w. Okay. A squared. 5 squared plus 5 3w plus 3w squared. Okay, so that's just going to give us 5 minus 3w, 25 plus 15, just cleaning things up, w plus, careful, the 3 wants to get squared also, 9w squared. Ta-da! That's it. Okay, so if we go back to 196, 196, it was n to the 6 plus 512. So 512, I think that might be 4. 4 times 4 times 4? No, maybe 8? 8 times 8 times 8? 8 times 8 times 8 is 512. How would you know that? I don't know, you just keep messing around until you find it. Okay, so 8 cubed is 512 for the record. So this is something cubed plus something cubed. N to the 6, how do I make that? Oh, that's n squared cubed. Oh, and 512 is just 8. Okay, so a cubed plus b cubed is just a plus b times a squared minus ab plus b squared. A is just n squared. A is just n squared. B is just 8. Okay, so just plug everything in. N squared plus 8, right? A was n squared. B was 8. Okay. N squared squared, n to the 4th, minus a times b, 8n squared, plus b squared, 8 squared, 64. Ta-da! Okay. Let's do one more of those. Probably need a new piece of paper. How tricky can they get? 210. 210. X plus 4 cubed minus 27x cubed. Something cubed, that's 3 cubed, and that's actually something cubed, that's x plus 4 cubed. Okay, so let's write this as something cubed minus something cubed. Well, the first one is kind of weird. It's just x plus 4. And this is a 3x. Okay. So if we were to do a cubed minus b cubed, you see how a is just x plus 4 and b is just 3x. So this is going to give us a minus b times a squared plus ab plus b squared. A minus b, x plus 4 minus 3x. Okay. A squared, x plus 4 squared, plus a times b, x plus 4 times 3x. Okay. Plus b squared, plus 3x squared, 9x squared? 9x squared. Does this clean up a little bit? Yeah, probably. X plus 4 minus 3x times, oh god. I would look in the back of the book at this point and see how much they cleaned it up. I'm not sure how much they cleaned it up. They might have kept cleaning it up. I don't know. Oh gosh. Yeah. Because I don't feel like multiplying this mess out right now. But you would have no problem doing that. Just clean up that piece. X plus 4 minus 3x. They might have left it like this. You never know. Should I look at, so we're doing 210. We're doing 210. Let's look at how they cleaned up 209. 209. Oh, they cleaned it up? Oh, God. Okay. Okay. They cleaned it way up. So I will clean it way up. Let's see, x and a minus 3x minus 2x plus 4. X plus 4 squared, x squared plus 8x plus 16. I foiled it in my head. I got 4x, get 8x. This one plus 3x squared plus 12x plus 9x squared. So that's a negative 2x plus 4. X squared, 3x squared, 9x squared. That's going to be 12 of them? No, 13 of them? 13 of them, good gosh. 8x, 12x, that's 20x. And a 16. Okay. And then this negative 2x plus 4, I can pull out a negative 2. So pull out a negative 2. It leaves me with an x minus 2, negative 2x plus 4. And this mess, 13x squared plus 20x plus 16. Does this break apart? I don't think it does, and I'll just stop right there. OMG. So I think, you should be able to handle 6.3. And then let's take a look at 6.4. I think 6.4 is just, now that we've learned all this stuff, 6.4 is just like, okay, here's a bunch of crazy problems. Figure them out. So let me take a look at 6.4. Is that what 6.4 is? 6.4, recognize and use the appropriate method. Okay, yeah, so they're just giving you a bunch of problems and saying, hey, figure it out. Sweet. Okay, so this is good for 6.3 and 6.4. And I'll make a little video for 6.5. 6.5. Oh, notice how there was no equal signs, technically speaking, in the given problem. So that's what's new in 6.5. There's going to be equal signs. But conceptually, 6.5 is not bad. It's just going to be one extra step. Okie dokie.